Hey there, it's your good old friend Mr. Hogan again. But we're going to talk today about some inverses, things like that. Kind of re-review those before we, kind of move on into anything new. We will be getting into some new stuff probably next week, but for this week anyway, want to have some of those re-review of things. So what we had left off with before, all our big break and the craziness that's happening right now, is we were working with these inverses, right? But this little negative one up there, we call it like arc sine, those kind of things. So the idea with inverses, what we were working with, is that our trig functions, our regular ones, sine, cosine, tangent, and the rest, they will usually take an angle and turn it into a fraction or a proportion. That's kind of that chapter 2, that's what that was talking about. So we have our sine and our cosine and our tangent, right? That's what those things do. They take an angle and turn it into a fraction or a proportion. Now what inverses do is they go the inverse direction. Inverse means opposite. So they go the opposite direction. So any inverses will take a fraction, proportion basically, of a triangle and turn it into an angle. That's what they will do, right? So for example, some that we'd had before is like our 30, 60, 90 triangle. If we draw that a little bit here, maybe about 60 degrees, here's 30 degrees, and here's our 90 degrees, and we can fill that in. We know our sides, 1, 2, and the square root of 3, right? We can put those around there. And we know that if we were to do, for example, say the sine, right, of 60 degrees, in other words, we used an angle, we used it in sine, it should give us a fraction or a proportion. In this case here, 60 opposite over hypotenuse, root 3 over 2. That's what we would get in that case. But an inverse is going to take this fraction and turn it back into an angle. We'd use our inverses to go back that way, right? So in that case, we could also write the sine inverse of root 3 over 2 should give us 60 degrees, right? And in fact, you could, use your calculator if you got one on you, and you can check that. That will work out, right? That's going to be okay. But the problem with this, right, this works just fine when we're working with, regular angles in between 0 to 90 degrees. That will work out just fine. But we know that in trig, we can go all the way around, 360 degrees. And that's where things get a little bit more complicated because we have to determine where the triangle is. Is it here, is it here, is it here, or is it here, right? Which quadrant is it in? And so we can't always know that, and we have to determine that. And the reason that comes up to be a little bit of a problem, right, is that this particular triangle, right, this one here, we can draw in any one of the 4 quadrants. It doesn't matter, right? We could draw that triangle right here, right? Here's our 30, 60, 90 triangle, square root of 3 and 2. I'm not going to fill it all in there. But this one here is our regular 60-degree angle. That's 60 degrees right there. But it could also be over here, right? It could also be down here, and it could also be here. We could draw that triangle in any one of those spots. Doesn't matter. And if we draw it here, this is a 120-degree angle, right? That's where that one is. Down here, we've got 180, 60 more, so I suppose that's 240 degrees. Here, we're 60 degrees short of a full circle. Oops, not 330. 300 degrees, I suppose that's what that one is. So we can put those around there, right? So we have our different angles going all the way around. Although they're a little bit different, right? They're a little different here. 120, I can still fill in those sides. But when we work down here in these lower quadrants with sine, they're negative because they're below the axis, right? Negative root 3 and 2. And negative root 3 and 2. So they're going to give us negative results, right? They're going to give us negative results on here. So when we go into here, I get that this is what our calculator has. I'm going to get rid of this for just a second because we'll talk about that. But in here, we could say, well, we could take the sine of 60 degrees, and we will get an answer of square root of 3 over 2, right? That's what that will equal. If we go over here and do the sine of 120 degrees, right? Again, we're using that angle. we will get a result of square root of 3 over 2. If we do the sine of 240, and we won't quite get that same thing, well, almost the same, but it will be negative. If we do the last one here, sine of 30 degrees, that will also be negative root 3 over 2. So then there's this little bit of complication here, right? If I do, now I'm going to rewrite that piece down here again, the sine inverse of square root of 3 over 2, right? Following our idea, we have a fraction, we're using our inverses, we want to get an angle, right? We want to figure out what it is. But there's a little bit of a problem, because this square root of 3 over 2 is either here, should get 60 degrees, okay. See if that shows up. But it could also be this one, right? What if we're talking about this? Maybe I should get 120 degrees. Maybe. Right? Which one's it gonna be, right? What do we know? 60 degrees or 120 degrees? Which one's it gonna be? And that's the difficulty, right? Same thing if we try to do the negatives. If I do sine inverse of negative root 3 over 2, I don't know, is it supposed to be 240? Is it supposed to be, 300 degrees? And that's the difficulty with those inverses. And your calculator, if you plug this in, will tell you 60 degrees. But why doesn't it tell you 120? It works, it's right here, right? In fact, 120 is a possible answer. But when you use your calculator can only tell you one particular answer. But then we kind of go through and say, oh, maybe there are multiple things that could possibly happen when we're solving equations. So what we have is we place a limitation on these inverses, right? We place a limitation on them. So for sine inverse, the limitation is that it can only exist, or it can only give you answers from positive 90, which is up here, backwards and down to negative 90. That's the limitation on sine inverse. And in fact, it's also the limitation on tangent inverse. Again, I'm using sine as the examples, but tangent inverse as well. Sine inverse and tangent inverse can only give you answers, right, if you're using your calculator, between 90 and negative 90. That's it. No other possibilities because of those repeated things. So your calculator has to pick, and the choice has been chosen to be here, right? There's some stuff we went over in class about keeping things as functions, things like that. But that's the main idea. We've got a mix of positive possibilities and negative possibilities, right? But for cosine, we have to change things a little bit. Because as you guys know, with cosine, if we stay in these two quadrants, we can only use positive things in here because cosine's positive in those two quadrants. So the choice was made a long time ago that cosine, when we use a calculator or anything else, arc cosine or cosine inverse will only give you answers from 0 to 180 degrees, right? That's where cosine will give you answers between. So some things to review on that, right? Yeah, we've got all this stuff. I'm going to summarize that stuff in here, right? So we're going to kind of clear this stuff out. And cosine can only, let's do sine inverse first. Sine inverse and tangent inverse of whatever our proportion is, right? Remember, this could be a fraction in here. Will only give you answers from negative 90 to positive 90. Same with tangent. Right? That's the only possibility that your calculator can give. And then when we're solving equations, we kind of have to go through and interpret, well, there might be multiple possibilities, right? We use our calculator to get the first initial one, and then we go around and figure out where else they could be. Cosine inverse, as mentioned in blue, can't just exist there because we'll only have positive options to work with because cosine is positive in these two quadrants. So we have to kind of adjust to where cosine is. So cosine can give us answers from 0 to 180 degrees. Right? That's our big takeaways from there. What that allows us to do, right, is like if I wanted to do this, the sine inverse of the sine of 150 degrees, right, inverses should be opposite. We should think that these would just sort of cancel, and this should tell us 150 degrees. Great, right? That's what we would normally think. But it doesn't quite work that way, all right, because of these limitations. So I'm going to erase this so we can get a little bit better picture going on. Okay. Okay. So for 150 degrees, and we'd have our axis here, 150 degrees exists over here, right? Here is 150 degrees. That's where it exists, right? And I don't really care, right? We could fill it in. I get it. It's a 30, 60, 90 triangle. But the thing is we're looking for, we should have the inverse on the outside. We should get an angle out here, right? It's saying what angle makes this triangle. We say, oh, 150 degrees. But again, sine inverse can only give us answers between positive 90 and negative 90. That's the only spot where sine inverse can give us an answer at. So we have to sort of reflect this triangle in here. We have to say, okay, where's this going to come to, right? What's the result going to be? So we have to take this same triangle, I'm going to erase that for a second, and sort of match it up in here, right? I have to keep the kind of same spots. So I'm going to keep this over here. It's going to reflect over to this spot, right? And say, okay, right, it's going to be in here. So here's where that is. And the angle for this particular triangle is not 150, it's only 30 degrees, right? That's the only one in there. So this, the result would be a 30-degree angle when all said and done. Well, that marker's not working very well. But it would be a 30-degree angle that would come out of here, right? That's what it would be. And if you plug it into your calculator, that's what you'll get. And so we kind of have to make those adjustments. And we'll do one other example, and then you guys can work out some on your own on there, but you can always send me an email or something like that too if you have other questions, if those aren't making sense. So I'm going to adjust this one a little bit. We'll do just a couple more just to kind of show what's happening on there. So let's say in here we wanted to do, let's switch it up. We'll go to like tangent, right? Similar idea. Tangent, and let's do something a little bit different, like 217 degrees. Let's just put that, right? Say like, okay, could we figure that out? Again, plug it in your calculator, you're not going to get 217 degrees, right? It's going to give you something else. So let's kind of figure this out, right? I understand that we could use a calculator if we wanted to, but we're not going to. We're going to pause, right? I want us to understand the underlying concept that's going on. 270 degrees. I'm going to start out by drawing out where is that at. So 217, there's 180, and then I suppose we'd go 37 more degrees past somewhere down in here. That is approximately our 217 degree angle. That's where it's at. Tangent inverse. Now I need to think about. Okay, again, tangent inverse wants to tell me what the angle is. Should be 270 degrees, but our calculators don't work that way, right? Tangent inverse will only tell me answers from positive 90 to negative 90. That's the only spot where tangent will tell me answers about, right? So now, in this, we've got to be a little bit more careful, because here's what most people might do, right? That same thing, we reflect back in and we say, okay, well, I'll take this triangle, I'll draw it right here because that's its reflection, and I'll pick the angle that fits in there. But it won't quite work that way. Here's where we have to go, right? I have to kind of keep in mind where things are positive at. So when I draw my reflection or my rotation, I'm drawing it so that it keeps positives and negatives, and it preserves those positivity and those negatives, anything like that. So here, tangent is positive in this quadrant, which is where our original triangle is. So when I reflect the triangle, I have to reflect it into a quadrant where tangent is also positive. So if we had taken this and reflected just kind of said, "Yeah, I'll just mirror it right here, right? Which is a possibility, right? I could mirror it here, right? There's a possibility. Or I could mirror it up here as well, right? I could mirror it there also. I get they don't look exactly mirrored, but right, I could mirror it. It's got to be one of these two spots, and we have to decide which one should we use, right? There's so many choices. But tangent is positive in this quadrant, right? Tangent's positive. So I want to find a quadrant where tangent is still positive. If we go here, tangent's not positive. It cannot be this one. So we'd say, no, get rid of you. Tangent's not positive there. It's negative. So it can't be in that spot. It has to be this one. And then we just kind of make our little bits of adjustments to figure that out. I know in this triangle, the reference angle is 37 here. So the reference angle of 37 degrees has to happen there. So this must be a 37-degree angle. If you type that into calculator, that's exactly what you'll get out. And that's why. I'm not saying you can't use a calculator. What I'm saying is we have to understand why does this happen, right? Why do we only get 37 degrees? And that's because of those adjustments and where that needs to go. Okay? Last example, we'll do one with cosine just to see how that reflects around a little bit. Okay? So let's do the same thing here, all right? Yeah, let's do this one here, right? Let's do this. What if I change this to the cosine inverse, the cosine of 217 degrees, right? Is a similar thing, right? That means I can keep this triangle very much in the same spot because there's a 217-degree angle. We're just shifting, whether you're using cosine or sine, just to get an understanding of what do these inverses do. Now the small adjustment we have to make, cosine only gives us answers from 0 to 180. A little different, but strategy-wise still the same thing. So here, cosine can only give us results from 0 up to 180 degrees, right? It can only give us results. So it's not going to return 270. 270 is down here in quadrant 3. The triangle has to be in one of these two quadrants, right? So then I would think, okay, what I'm going to do is take this triangle, mirror it or reflect it up into one of these two, right? But I have to decide where does it need to go, right? It could be here, it could also be here. Which one makes the most sense, right? Here, cosine is negative. So I need to reflect this into a spot where cosine is still negative. If I reflect it up here, it will turn it into a positive cosine value. And we don't want that, right? We want to keep cosine being negative, right? So that means I have to reflect it into this quadrant because cosine is negative in this quadrant. So I would reflect this here, and I erase this just a little bit so we can see that. I reflect it into this quadrant here. I'm going to reflect it here. So in this case, we want to find out what's the angle that leads from 0 up to this guy in that spot, which we can do that just a little bit of math. We know again we got a 37-degree reference angle in this bottom one, so that means the top one still has to be a 37-degree reference angle. So we go from 180 back up 37 degrees. So we don't have that, and then I just say, oh, it equals 180 minus 37 degrees, right? Which now we just do a little bit of mathiness and figure out, okay, that's going to return a 143-degree angle. And that's the limitations with those inverses, all right? So some of the other stuff that we'll look at is, how do we, use inverses to solve different things? How do we use inverses to solve equations will be the next kind of review thing that we do as well.